Hey guys, welcome to this lesson. In this lesson, I'm going to cover the Amazon Virtual Private Cloud, VPC. So a VPC is created within an AWS region. It's actually a logically isolated portion of the cloud. So in other words, what you create within that VPC is only visible and accessible from within your account by default, unless you launch resources that you want to be publicly available. So we can isolate it from other customers on AWS. We can isolate it from other VPCs even within our AWS account. So within a VPC, we can create subnets, and those are actually mapped to availability zones. So the availability zones themselves, of course, those are data centers, and we can use those availability zones for lots of different VPCs in that region. But the subnets within a VPC are mapped one-on-one to an availability zone. Now, of course, we can create multiple subnets in each availability zone as well, but a subnet will not span across availability zones. So we create the subnets within an availability zone, and then we can launch our resources. You can launch those into your subnets. For internet accessibility, we can then attach internet gateways if we want to be able to connect outside the VPC to the internet or to other networks. Within the VPC, there's a router. Now, you don't see this as a device that you actually can create within a VPC. It's behind the scenes somewhere. And the way that we manipulate the router is through the route table. So we define the routes, and that's configured in the router behind the scenes for us. When we create a VPC, we define the CIDR block. That's the classless interdomain routing CIDR block of IP addresses, and that's the overall address range for the VPC. So the route table is used to configure the VPC router and define how we want to route traffic either within the VPC or outside of the VPC. Now, we can create multiple VPCs within each region. Each VPC will have a different block of addresses. That's not actually mandatory, but it's certainly recommended. We have something called a CIDR block. CIDR stands for classless interdomain routing. This is the overall block of addresses that we assign to the VPC. Each subnet will then have a block of addresses from the CIDR block. It's actually a subset of the addresses from the overall CIDR block. So we have our CIDR block, which in this case has a 16-bit subnet mask. Then we create our subnets, and in this case I've used 24-bit subnet masks. So I have subnet 1, 2, 3, and 4. On the right-hand side, I have another VPC. It has a different CIDR block. It's 10.1.0.0 rather than 10.0.0.0, also with a 16-bit subnet mask. And then I can create my subnets within that CIDR block from that overall address block. So now I have subnets 1.1, 1.2, 1.3, and 1.4. So let's just go into that in a little bit more detail. So the CIDR block here, we have 10.0.0.0. It's got a 16-bit subnet mask. That means 10.0 are going to be the same for every network and every computer within this particular CIDR block. However, we can then subdivide. So of course we represent that as 10.0.0.0/16. Then we create our subnets. So I've got 10.0.1.0/24. Okay, so now we've taken some of these bits and we're using these for the network ID of this particular subnet, and now it has a 24-bit subnet mask. So the VPC subnets will always have a longer subnet mask than the CIDR block by taking additional bits from the host portion and assigning them to the network portion by having a longer subnet mask. So now the subnet mask looks like this one. Then I can create 10.0.2 and 10.0.3 and so on. This is why it's super important to understand IP addressing when you're working with the cloud, especially in VPC, because you will need to know how to correctly create the right CIDR block and subnets within that CIDR block, and make sure in most cases that they're not overlapping with other VPCs, because that can cause problems with some services like VPC peering and AWS Transit Gateway. Now, last concept I want to cover quickly here is that there are some services that we say are in the public space of AWS and some that are in the private space of AWS. So what we mean here is some services are within a VPC and some are not within a VPC. That's basically the crux of it. So here we have EC2 instances. They're always within a VPC. RDS databases are within a VPC. as is the Elastic File System here. Now, other services like Amazon S3 sit outside of the VPC, so we say that that's the public space, and they are directly accessible from the internet. So private services can have a public IP address, but they exist within that private space of the VPC. So here the instance in the public subnet might have a public IP address, whereas the instance in the private subnet won't. However, in both cases, they are sitting within a private space where we have full control. Public services have public IP addresses and endpoints, so they're directly accessible from the internet. Now, just because a service sits in that public space does not, of course, mean that anyone can access it. You still need to have the appropriate permissions, and in some cases, you'll need to find a way to authenticate using another service before you're able to access those services. But they do have those public endpoints if you want to be able to make that service accessible in some way from the public internet. So that's the difference between public and private. And for our instances, they're always going to be in that private space, which means we need to create our VPCs, we need to create our subnets across different availability zones, and then launch those resources into our virtual private cloud.